All right. Yesterday, I think we left off. What was the last one we stopped at, Lily? Lily, what was the last one we stopped? Anybody? Help? Okay, that's right. All right, so this is where we stopped yesterday. That's fine. I'm going to do it again just to make sure that we're all on the same page. All right, so here's the deal. So we've got this compound that we've got to figure out. And when you look at it, you're like, wow, that's a bunch of letters, and I don't necessarily know how to deal with this thing. But, and that's just like I told you guys yesterday to end the class, you have to recognize this thing as an entity. And what is that thing? Ammonium. Okay? I can't stress to you I cannot stress to you how important it is that you recognize the polyatomics. I cannot stress to you how important it is. All right, now, Brandon, S. S by itself. Okay, so you know it's not 8 or ite. What is it? Ite, I-T-E. Very good. So it's ammonium sulfide. Okay, we're good with that. All right, so today we're going to pick back up and we're going to look at this one. So Li2CO3. All right, so my first question, Blaze, what is Li? Lithium, is it a metal or non-metal? It's a metal. So we know that this is probably going to be what type of bond? Ionic. What will we not have anywhere in this name? Any prefixes. All right, so you just told me the lithium was a metal. Now, is it a transition metal? So what do I not need anywhere in there? What do I not need for that? No Roman numeral, right? Okay, so here's the deal. Then we've got this thing. And this is for everyone. This is a yes or no. Do you recognize that as a polyatomic? Yes. My question is, do you know which one it is? Johnny, which one is it? Ashwini, what is it? CO3. Maya? What? Ron Howard? You're next! What is it? Yes. So, I heard it over here. I did hear it over here, but I was making sure that this side of the room was with us. So, this is it. You're done. All you did was just name what you see. That's literally all you did. But again, the issue is that little bitty 2. Why is this not dilithium, Marquise? Very good. It's ionic. And ionics do not have what? Prefixes. The second thing is, why isn't it not lithium 2 carbonate? It's not a transition. And even if it were transition and it did need a Roman numeral, would this even be the right one? Okay, very good. So that's got to go away. So technically, who does that 2 belong to? Technically belongs back here as a 2 minus, but we'll kind of get to that in a second. So just keep that in mind as we go through this. All right, so the next one is KCN. KCN. All right, Gage, what is K? Potassium. Is potassium a metal? Yes. So what type of bond are we working with? Ionic. So what will we not have in these names? Prefixes. Do I need a Roman numeral in this problem? Why not? Very good. So then I've got to come over here. And again, this is the one that gets people a lot. They see that and people want to put carbon nitrogen or carbon nitride or some kind of crazy stuff. What is that, Gage? Huh? Massimo, what is that? Shh, don't say it out loud. No, you. Massimo. This is everybody else. Sharon, what is it? It is a polyatomic. Which one? Very good, Sharon. Cyanide. What did I just say? Oh, okay. Never mind. Potassium cyanide. Yes, this stuff will kill you. Okay? That is a poison. Yes, that is a poison. So, yeah. Well, cyanide is the ion. It's got to be hooked up with something else. No, cyanide is the poison. but you can't just have pure cyanide. It has to be in a compound. Okay? All right. Now, these next three, I'm going to go ahead and forewarn you. These are the hardest three to do. These are absolutely the hardest three types to be able to figure out. So I would strongly advise paying attention to this. Okay? Alan, this is a tough question. What element is SB? We don't use this one very often, so you're probably going to have to look this one up. Alan? It's not anti-money, everyone. Antimony. Okay? This is antimony. Now, here's my question, and it would probably help if I pull this back up from yesterday. Let me actually bounce out of this. Let me go to this. Is it still there? Hey, looky there. It is still there. Go away, Mr. Whatever you are. Clear this. So my question is, where is antimony? It is right there. So, is it to the left of the stair-step line? Yes. Is it in our blue boxes? No. So what are we going to have in this thing? We've got to have a Roman numeral. So I'm going to come back over here, and I'm just going to put a blank for right now. We'll come back and we'll fill it in. But the next part, Marquise, what is that NO3 thing? It is nitrate. Very good. So it's antimony something nitrate. All right, so on this line, we got to put an RN in it. And what is an RN? Roman numeral. And where do Roman numerals come from? From the charge of the TM. All right. What is that process called in order to find the charge? Very good. You're remembering. Reverse crisscross. All right. So technically, what is back here behind this SB? A 1. So I'm going to pull this back. It's a 1 minus. And this 5 technically belongs up here to antimony. But again, remember, this is the hardest part about making sure that all the stuff is right. What do you have to check in order to make sure both of those orange numbers are correct? Check that number right there. And if you don't know the charge on nitrate, you are in trouble because you won't know if it's right or wrong. Is that correct for nitrate? Yes, that is correct. So if nitrate is correct, then antimony must be correct. Okay, so Brett, what is the Roman numeral for 5? V, very good. Again, and I keep begging this just for my sanity, please put the bars on tops and bottom of your Roman numerals. Again, I'm not going to mark it wrong. Just please be nice and do it just because I asked you to for courtesy. Doesn't take 2 extra seconds to do it. So that is that one. Now let's look at the next one. CuNO3 2. All right, Maya, Cu. Who is Cu? It is copper. Is copper a metal? Yes. Is it a transition metal? Yes. So what does it have to have? It's got to have a Roman numeral. I'm going to put a blank for just a second, and I'll come back to it. By the way, when you're doing this on your own, do you have to put a blank? No, I do it just for space. Is this still? Wow, how about that? And then what is NO3, Maya? Nitrate, very good. Okay, Terrell, so now I got to figure out what it is. So what is that process called in order for me to determine this number right here? All right, so what's technically right here behind this Cu? A 1, so I'm going to pull this back. And so that's a 1 minus. This 2 technically belongs up here to copper. All right, so Terrell, so the tough question. Is this number right for nitrate? Yes. So if this checks off, then that checks off. So what's my Roman numeral? Very good. So it's copper 2. Copper 2 nitrate. Alrighty. And the final one, I'm going to change things up on you. Go to the bottom right one, because the bottom left one I'm going to let you guys do in just a second. So PB SO4 2. All right, Baker, what is PB? It's lead. Is lead a metal? Is it a transition metal? All right, so let's go back and look at this. Lead is sitting right here. Is it to the left or to the right of that stair-step line? Left. Is it in one of the blue boxes? No. So it has to have a what? RN. Roman numeral. Okay, it's got to have a Roman numeral. So here's the deal. So I'm going to put a blank right here. Baker, what is SO4? It is sulfate. Real quick, this is for everybody. Hypothetically, if I change that to SO3, would it change the name? What would it change it to? Sulfite. Again, hypothetically, if I changed it to SO2, would it change it again? But what would it be? Hyposulfite. Again, all hypothetics. What if I changed it to 5? Hyper or just per sulfate. Just throwing all those things at you, but we're just going to stick with the 4. No, per means one more oxygen than 8. You with me? All right. Now, here's the problem. Again, what's the process called to find out my charge, Baker? Reverse crisscross. So what number do I have sitting right here? A 1, so I'm going to pull that back, so I've got 1 minus. This 2 technically belongs up here to lead. And Baker, this is, again, the hardest question. You've got to remember this. Is this number correct for sulfate? Is it, anyone? No. What is it supposed to be? 2. So what do I do to both of those numbers? Very good. I'm going to multiply both of these things by 2. That gives me 2 minus. This gives me 4 plus. And now, I know. Now, this is a pure, genuine question. Please be honest. How many of you don't know the Roman numeral for 4? Emma, what is it? Very good. Just what? What? Yeah. All right. So lead 4 sulfate is the name again. The reason this one was a little weird is because of this right here. That 1 negative is wrong, so we got to correct it by multiplying it by what it's supposed to be. All right, so here's your objective. I want you to take a few minutes, and I want you to work down the right side of that column and see if you can get all of those correct. Okay, it's important that you work on this today because Thursday you're not going to have this opportunity to be able to do all this. All right, Blaze, start with you. MgBr2. Stop. Okay. So, Mg. What is Mg? Magnesium. Is it a transition metal? No. So, what do you not need? Does it have one? Well, how about that? A long time. So, is it a transition metal? So, what do you not need? You don't need a Roman numeral, okay? So, finish the rest of it. Okay? Blaze, why is it not dibromide? It's ionic, and what do we not have? Prefix, very good. Another question, why is it bromide and not bromate? Bromate is what? BrO3. I see no O and I see no 3. You with me? Okay. All right, Jesus. The next one. AlCl3. Jesus, what's Al? Aluminum. Is it a transition metal? No, it is not. So what do you not need? Or? Very good. So finish out the rest of it. Chloride. Why isn't it not trichloride? What type of bond are we working with? Ionic. And what does ionic not have? Does not have prefixes. All right. Roll me. The next one. Ba3N2. Very good. Continue. Very good. Why isn't it not nitrate? What is nitrate? There's no oxygen, and there's not three of them. Let me, guys, give you a little silly thing that always works for me. How many of you like playing hide-and-go-seek growing up? When you play hide-and-go-seek, did you hide with a group, or did you hide by yourself? You should have hidden by yourself. That's the whole method of the game, right? So here's how remember. You hide by yourself. Okay? So that's a little way that I remember. If it's an element by itself, it has to end in ide, I-D-E. Because all the polyatomics end in ate or ite. Now let me throw this at you. There are 3 exceptions. Things seem to always come in threes. There are 3 polyatomics that end in ide. Does anyone know who they are? Cyanide, that's one of them. Peroxide is one of them. Very good. Those are the 3 polyatomics that end in ide. Now, we've already done cyanide. What is cyanide's formula? Cn negative, peroxide. O2, 2 negative, and then hydroxide. Very good. OH negative. So again, when you see these 3, they'll always be written second, and they'll never be, well, peroxide is kind of by itself. It'll always have the 2 there. But these are the only 3 exceptions. So like I said, when you see an element by itself, like nitrogen, or the previous one, chlorine is by itself. Or when you see bromine by itself, it ides by itself. Cool with that? All right. The next one, ZnF2. All right, what is Zn, Emma? Zinc. Okay, that one. Hey, here we go. Now, Emma, why does this one not need a Roman numeral in it? Very good. It only has 1 charge. And what is the charge of zinc, Emma? 2. Now, the rest of it is fluor. I did it again. It's not flour. Fluoride, ite, or 8. I'm not finished. That's right. I'm not finished. What does it end in, Emma? This spells it as UO. Look it up, dude. No. Just when you write it and you read flour, say, "Whoa, that's wrong. I need to swap these back." I'm not gonna count that off, but I wouldn't spell your name R-B-O-Y-N. You're not Bert. You're Brett. So why? You're not going to call it fluoride. You're going to call it fluoride. Stop, Bert. Just quit, Bert. Keep going. All right. Thursday. I don't know. Look it up. So, now my next question is, Brennan, Ca, what is Ca? It is calcium. Now, here's the deal. See, y'all got me misspelling stuff. Now, this next one, is P by itself or is it with something else? So it's not iding by itself. Now, who, is that right? No, that's wrong. That is a 3, my mistake. So it's PO3, 2. So what is that polyatomic? I'm talking to Brennan. Brennan? It is ite. Very good. It is calcium phosphite. Guys, y'all please stop. Next. Now, this is the long one. These are the ones that always kind of freak everyone out, but in reality, It's one of the easiest ones because it jumps right off the page at you because you know exactly what it is. Even though there's a lot of letters and it looks really long, it's really not complicated. So Jalen, what is Al? Aluminum. Now, Jalen, do I need a Roman numeral in this? No, very good. And what is that big, long, crazy polyatomic? Acetate, very good. So like I said, when you see these formulas, don't let them freak you out because they're really not that complicated. Prime example, if I give you one that looks like this. Your mind does not like that. There's too much going on, there's too many numbers, there's too many letters. But when you actually look at it, if you break it down how I've taught you to break it down, between the polyatomics, it's really simple. So if you split this, what's right there? Ammonium, and you already know that's ammonium acetate. So don't let the overwhelmingness of one of the polyatomics shut you down because you know it if you just focus on what the individual parts are, and you've got to connect that. Now, would it be easier if it were written like this? No. The only time you use parentheses to protect the polyatomic are when? If there is a number. So prime example, let me show you two different types. If I've got NH4 2S, or I've got Ca C2 H3 O2 2. The only time you put a polyatomic in a parenthesis is to protect it from a number behind it. Because if you took the parenthesis off right here, it would look like 42, and that wouldn't make sense, right? If you took that off, it would look like 022, and that doesn't make sense either, right? So you have to put those parentheses in only to protect them. But here's the deal. So when you do ammonium, you guys know ammonium as what charge? 1 positive. Acetate is C2H3O2, 1 negative. Well, what happens to the charges? They cancel, which is why it's just an H4C2H3O2. Okay? All right, so let's move on to the next one. Same exact example here that we just kind of gave. Tristan, what is Ag? Silver. Is silver a transition metal? Yes, but is this one of your exceptions? Yes, so do not ever put a Roman numeral on silver. If I did have to have one, what would it always be? Silver is always a 1. Okay, now, nitrogen by itself or with something else? It's with something else, so it's going to be either 8 or ite. What is it? What is it? Nitrate. Very good. Okay. Now, let's do these two because these are the ones that's going to trip people up. So, NiS. Lily, what is Ni? How do we spell this thing? Nickel. Now, is it a transition metal? Yes, so I'm going to leave a blank for just a second. All right, Lily, so what S, is it with something or by itself? So what's it going to end in? Ide, so it's sulfide. Now here's the deal. I'm telling you now, these are the ones that's going to trip you up if you don't pay attention. How do I find that Roman numeral? What do I do? Reverse crisscross. So what's understood to be right here? A 1. What's understood to be right here? A 1. So I've got 1 plus and I've got 1 minus. But again, what do you have to do to make sure that this is right? You've got to check this one right here. And Lily only, is that right? No. What is it supposed to be? 2 negative. Baker, how do you know that's supposed to be a 2 negative? Michaela, how do you know it's supposed to be a 2 negative? No, you don't. I'm asking, no, I want people. And what group number is it in? Stop telling her. And what is the charge of all group 16? You sure about that? Yes. Okay. All right. So that's going to change this to 2 plus and 2 minus. So what nickel is this, Lily? Nickel 2. Okay. Again, I get a lot of nickel 1s here because people don't pay attention to that back one. Okay. Be very careful here. All right. Moving on to the next one. We've got Fe. Cl2. All right, Brett, what is Fe? What is Fe? iron. Thank you. Is iron a transition metal? So what does it have to have? It's got to have an element now. Chlorine, is it by itself or with something else? It's by itself, so how's it hiding? It's hiding by itself. Okay. Now, Brett, how do I find out this Roman numeral number? Reverse, so I'm going to take this 2 and give it back to fluorine, and I'm going to take that 1 and give it back to chlorine. Is this correct? Yes, so that means it's going to be iron what? Iron 2. Iron 2. All right, and then, what? Okay, and then the other one that I did not do on the other side is AuCN3. All right, Marquise, what is Au? Gold. Is gold a transition metal? Yes, so what do I have to have? Roman numeral. Now, how do I get that thing? Okay, so my question is, first of all, what is Cn? Cyanide. What is the charge on, wow, I just misspelled that. What is the charge on cyanide? Is this correct? Yes, well if that's the case, then gold is gold 3. Yes, yes sir. Yeah, I like that. Go for it. All right, so let's do 3 of the ones at the bottom real quick so we can kind of have something to attach onto tomorrow. So now we've got to go from the name to the formula. Now, there's got to be a lot more thinking involved in this one because you've actually got to know charges to be able to figure this one out. Okay. All right, Alan, what is the chemical symbol for silver? AG, this is for everyone. What is this charge of silver always? It's always a 1+. Now, I can't help you memorize that. I'm asking you to memorize 3, and 3 only. And this is one of them. Silver's always a 1+. That's why there's no Roman numeral in here. Okay? Sharon, what is the symbol for iodide? I. And what group is iodine in? So what's this charge always going to be? Okay? So what happens to those two charges, Sharon? They cancel out. So what's your final formula? Very good. AgI. That's the final answer. Okay? All right, Massimo. Magnesium nitride. All right, Massimo, what is the chemical symbol for magnesium? Mg, guys. Please do not confuse it with Mn, which is manganese. All right, what group is magnesium in, Massimo? 2, so what's this charge always going to be? 2+. Gauge. Nitride. What is the symbol for that? N. Okay. What group is it in, Gauge? 15, so what's this charge always going to be? All right, so Gauge, do those charges cancel out? Nope. You can do 2 things. You can set them equal to 0 and do the math, or you can simplify it and do what with those numbers? Crisscross them. If you crisscross them, you don't have to do any thinking, any math. So when you write your final formula, what's the answer? Mg3N2. Now, does this seem a little easier? The hard part is making sure that you do the charges correct. Because if you get the charges wrong, is your formula wrong? Yes, that's going to be the key part. Brandon, what was that O for? Just so I can clear it up with everyone else. Does it make sense? Good. Okay. All right. Johnny. Zinc chloride. Johnny, what's the chemical symbol for zinc? Zn. Now, it's in the transition metal location, but there's not a Roman numeral. It's an exception. And what is zinc always? It's always a 2+. Guys, this is one of the other ones I've asked you to memorize. Silver's a 1, zinc is a 2, and what's the other one I've asked you to memorize? Cadmium, and what is it? 2. It's always a 2. All right, so Johnny, coming down, Baker, chloride. What's the symbol for that? Cl. What group is it in? So what's this charge always? -1. So Brandon, what do I do with those charges or those things? Crisscross. So if I bring it down, I don't have to do any thinking. And if you want to set it equal to 0 and do the math, totally cool with that, but that's a waste of your time. So what's the final formula? ZnCl2. See if you can do aluminum fluoride, and we will stop there if you get it right. Aluminum fluoride. Just do that one. We'll stop there if you get it right. Because potassium permanganate is going to be one we got to talk about. Aluminum fluoride. All right, Robin, what is the symbol for aluminum? Al. And then what group is it in? So what's this charge always going to be? 3+. Now, Michaela, fluoride. What's the formula? Just fluoride. F. What group is it in? So what's this charge? All right, think about this. How many valence electrons does group 17 have? 7. How many does it need to have? So how many more does it want to gain? 1. So what's this charge? Does that make sense? Does that help? Now what do I do with these numbers? Okay, so what's my final formula? Remember, do we bring the signs with it? Leave them out. So ALF3. How many of you got that right? 2 people got that right. 3, 4. Good. Stay seated. Stay away from my door. Bailey tried to leave yesterday. She's out too.